All right, guys. We're going to go over the review sheet today, and your test is tomorrow. Now, the first 1 through 6, we're talking about direct and inverse variation. Now, direct variation, the standard form, is y is equal to a times x. We could do it in either way. We could say x is equal to a times y, but in this form, x and y are on opposite sides of the equation. Both are in the numerator. Our other version of this is y over x equals a. We could say x over y. It doesn't have to be y over x. We can have it in either way. Equals a number. Our inverse. Because it's just two variables being divided. Because the only thing that would change is if we had x over y, the a value would be flipped. So it'd be 1 over a, but that's still just a. So if x over or y over x gave us an a value of 2, x over y would just be 1/2. It just flips the ratio. Now for inverse, we have y equals a over x, or x times y is equal to a. And if we have it in either one of these forms, it is inverse. And we can go through these pretty quickly, because if we look at number 1, it would be direct. Number 2 is inverse. Even though the y is in the bottom of the fraction, it's still the same thing as y equals a over x, or x equals a over y. Number 3 is neither, neither, and the big giveaway is the plus. Number 4 would be inverse. Number 5 is direct. And number 6 is neither. Yeah, number 5, even though it's x over y, that's going to be the same as y over x. They're similar in form. It would just be y over x would equal 1/8. We're just flipping it. Questions on 1 through 6. Seven through 19, perform the following operation. So with 7 and 8, with addition, subtraction, we need the denominators to be the same. But with both of these here, the denominators are already the same. So we would add the numerators for this one here. U plus 6u is 7u. V minus 3v is negative 4v over 8v. Is there, after we finish simplifying the numerator, is there a greatest common factor between 7u and 4v? No. Is there any way we can simplify the top and bottom? No. So that's it. Because we want to do all the steps for adding and subtracting, simplify the numerator, factor, and if there is something in common on top and bottom, we'll simplify it out. Now for this next one here, are the denominators already the same? Yes. Can we factor a squared plus 3a plus 2? Yeah. Now we could do this first or we can do it last because it comes in either order. Now if the denominators had not been the same, then we would need to factor them to figure out what we need to do to make them be the same. So here, since we're going to have to do it eventually, we might as well go on and factor it. There is no greatest common factor, and that's what we really need to look for first. So there's not one. But since the third term's positive, the signs are the same and match the sign of the middle term. Our only factors for a squared are a and a. 1 and 2. And luckily, the other denominator is the exact same, so it should have the exact same factors. Now we can add the numerators. Which will tell us that 4a plus a is 5a. 4 plus 1 is 5. Any questions on how we got to this point here? Now, we will be done as long as nothing simplifies or factors. Is there a greatest common factor between 5a and 5? So we can factor it out, which leaves us 5 factored out of 5a is a, 5 factored out of 5 is 1. Here, after doing that, we do have something in common on top and bottom. So the a plus 1 and a plus 1 will simplify, leaving us with 5 over a plus 2. Any questions on any of this here? Now, for the most part on the test, most of the addition subtraction won't simplify, but it's going to be good to check. Now, looking at the next one here, number 9, are the denominators the same? No. But to get them to be the same, the one on the right needs x plus 7. The one on the left needs x minus 8. Now we can multiply them together. Now the denominators, we don't need to multiply it back out. We can leave it as x minus 8 times x plus 7. Because again, that's going to become just the denominator itself. Now the numerators, we are going to have to combine like terms. We're going to have to actually subtract them. Since we are going to subtract them, we do need to distribute. 3 times x is 3x. 3 times negative 8 is negative 24. Here we're going to distribute the 4. 4 times x is 4x. 4 times 7 is plus 28. Now the first one, the 3x minus 24, won't have any impact with signs. But since we're subtracting the 4x plus 28, that sign is going to have to be applied to it. Which is going to tell us that we have 3x minus 24 minus 4x minus 28. If you feel comfortable, especially distributing that negative through, we don't necessarily have to write it with the parentheses. We could have just written it as 3x minus 24 minus 4x minus 28. Or we could do it with parentheses here and then distribute it through. Now we need to combine like terms. 3x minus 4x is negative x. Negative 24 minus 28 is negative 52. And again, at this point here, everything in the numerator is simplified as we can get it. We just need to see if we can factor. Is there a greatest common factor between x and negative 52? No. We have negative 1, but factoring that out won't give us anything in common on top and bottom. So that's it there. Any other questions on any of this here? Questions on addition, subtraction? Do we have any questions about number 10? Okay. We can look at 11. Now with 11, 12, and I believe 13 are complex fractions. We want to multiply the entire numerator and denominator by an expression that will cause each of the individual fractions to simplify. So if we look at the numerator, it has a denominator of 4. So if I multiply 5/4 by 4, the 4 and 4 will cancel and simplifying it down. If we look at the denominators, well, we have x minus 1 and x. So for this one here, we end up having to multiply by each of the denominators, mainly because each of the denominators' values don't repeat, because 4 only shows up once, so we need it once. X shows up once, so we need it once. And x minus 1 shows up once, so we'll need it once. Now what we'll do is multiply all the terms by it. So the top we're going to have 5 times 4x times x minus 1. Each one of the denominators will have 6 times 4x times x minus 1 over x minus 1 plus 7 times 4x times x minus 1 over x. And when we do this here, some of our terms will simplify. In the numerator, the 4 and 4 will simplify out. In the denominators, the x minus 1 and x minus 1 will cancel. And here the x and x will cancel. Now what that leaves us with in the numerator was we have 5 times x minus 1. Because that's all we had left on top. In the denominator, the first one here is 6 times 4x. Well, 6 times 4 is 24x. Plus 7 times 4 is 28 times x minus 1. So at this point, I've done some of the multiplication. I haven't done all of it. If we were multiplying, but because of the plus in the middle, we can't just cross it out. It is. Because in the denominator, we still have the 24x, but we do need to distribute the 28, which will give us 28x minus 28. Because we still need to combine like terms, especially with the 24 and possibly a like term with our 28 times x minus 1. So we can see after multiplying it, we do have like terms that will need to be combined, yes? Is there any other addition, subtraction happening in the numerator? Well, 5x is being multiplied by x minus 1, yes? Is there anything else added to it or subtracted from it? So is this here already factored? I could multiply the 5x through, but if I'm wanting to find like terms on top and bottom that we can simplify, I have to have it in factored form, yes? So we can leave it alone. Last thing we need to do is 24 plus 28 is x minus 28. Really, this is as simplified as it gets. The only way we can simplify it further is factoring out of 4, because 4 goes into 52 and 28, which would give us 13x minus 7.
So on mine, you did distribute
5x, and then we factored it right back out. Yeah, I was going back and forth between doing that and showing that, so either way works.
So, like on the test, if I do factor it out, but it's not necessary, is it still going to be fine?
Yeah, because we could have multiplied it through and then seen, okay, nothing combines, pulled it back out, you get to the same spot. It's just one additional step. Nothing wrong with it, it's just we end up undoing it in the end. Questions on any of this here? Questions on 12 or I think 13 is the same, yes?
Can we do 12 or 13?
Let's do 12. 13's, I believe, just a step above what most likely is going to show up.
Yeah, 13's a little scary.
Now, looking at 12, again, we need to simplify the fractions in top and bottom. So what's one of the things we need to multiply everything by to get the fractions to simplify?
X minus 3, x plus 1.
X minus 3, yes. and x plus 5. Now this one here has an x plus 5 that does appear in the top and bottom of the fraction, but in the numerator, in each of the fractions on top, the x plus 5 appears in the bottom of the fraction only once in each spot. In the bottom of the fraction, the x plus 5 only appears in each of the fractions denominators once. So we only need it once. Now we can multiply through, so the numerator will have 3 times x minus 3 times x plus 5 over x plus 5. Now, as I'm writing this out, we don't necessarily have to do this, because if we know the x plus 5 and x plus 5 will cancel, we could just rewrite the numerator as 3 times x minus 3. The denominator, we could say 2 times x minus 3 times x plus 5 over our x minus 3 plus x minus 3 times x plus 5 over x plus 5. But in the numerator, our x plus 5 and x plus 5 cancel. And one of the fractions in the denominators, the x minus 3's cancel, and the others, the x plus 5's cancel. So what that leaves us with in the top of the fraction is 3 times x minus 3. The denominator is 2 times x plus 5 plus x minus 3. Any questions on this here?
Now we have to leave the 3s alone for now. We can't cancel them.
So we can't cancel the x minus 3's on top and bottom yet because of the addition in the denominator. Because I have 2 things being added. I have these 2 added together, and there might be some like terms that need to be combined. Because if they are, we'll need to combine them first. The numerator, do we have anything actually added or subtracted to it? So we can leave it as 3 times x minus 3. I mean, we can multiply the 3 through, but if there is an x minus 3 on top and bottom that simplifies, we have to pull the 3 back out. If it's a single term, one term, nothing else being added or subtracted, we can leave it alone. Here, because we have 2 terms being added, we need to multiply through. 2 times x is going to be 2x. 2 times 5 is plus 10. Plus x minus 3. Now we combine like terms in the denominator. 2x plus x is 3x. 10 minus 3 is plus 7. Question of how we got to this point here. Is there a greatest common factor between 3x and 7? Now 7's prime. So there's nothing in common on top and bottom, so this is, yeah. Because I know we have a 3 out front in the numerator and the 3x, but again, we can't mess those, we can't cancel them out because the 3x is being added to the 7. If they had been multiplied, 3 times x plus 7, then they would simplify. Because we think of this as a single term. The numerator, we technically have 2 things multiplied. Any other questions on this here? Let's look at 14. Multiplication and division next. Whenever we deal with multiplication, the first thing you need to do is factor all of them. Now, if you come across one and it's already, the numerator and denominator are already parentheses being multiplied together, it means it's already factored. We don't have to do anything with it. Now, the x plus 7 is already factored. The x minus 8 on bottom is already factored. So the other 2 need to be factored. Now I'm going to look at 7x plus 35 first. Is there a greatest common factor between 7x and 35? 7. So if we take 7 out of 7x, we're left with x plus factoring 7 out of 35 we have. And the last one we have to factor is x squared minus 3x minus 40. Well, since the 40 is negative, our signs are opposite. Only factors of x squared are x and x, yes? Do we have anything in common on top and bottom yet? No. So at this point, nothing's going to simplify. But when you see the factors of 40, which are 1 and 40, 2 and 10, not 2 and 10, 2 and 20, 4 and 10, 5 and 8. 5 and 8, which one's positive, which one's negative? 8's negative, yes? Because negative 8 plus 5 would indeed give us a negative 3. But with this setup, we know the x minus 8 and x minus 8 will cancel out. And when we multiply, we know that the x plus 5 and x plus 5 will cancel out, leaving us with x plus 7 over 7. And again, we think of the x plus 7 as a single term. Addition, subtraction, bonds them together. They're stuck together. Multiplication, a little more fluid. Questions on any of this here?
So does it matter if it's negative? Oh wait, never mind. I see.
Yep. Questions on 14? So even if one of them, especially with multiplication, shows up as already, everything's in parentheses already factored, just start multiplying, simplifying. You don't have to do anything to it. Questions on 15 or 16? Because mostly multiplication is just factoring. We factor, simplify. Division. You can. We'll look at 17. But the main thing I would do is keep, change, flip. Just so we remember, and then I would factor. Because the first one's going to stay the same. We're going to flip the second. And then we'll factor. Now on the test, there's not going to be one that's just simplified as it is, where nothing cancels. Okay? It's not going to be, we factor this out and hey, nothing simplifies on top and bottom. There will be stuff that simplifies on top and bottom. I'm going to do the x squared minus 4x minus 5 first. Since, again, no greatest common factor, since the 5's negative, our signs are opposite. Factors of x squared are x and x. Those are the only factors of x squared. Factors of 5 are 1 and 5. Those are the only factors. Which one's positive, which one's negative? Negative 5, positive 1. Because our middle term is what? Negative, so we want the bigger number to be negative. And part of the reason I chose it first was, well, x squared only has one set of factors. 5 only has one set of factors. So there's a small amount of arrangements for it. That's supposed to be a 20, not 26. Doesn't matter which one we do next. I'll do x squared minus x minus 20. I'm just picking one of the two on the top. Here, since the 20 is negative, our signs are positive and negative. Factors of x squared are x and x, the only factors. Now 20 is 1 and 20, 2 and 10, 4 and 5. Which one do we want? 4 and 5. Because we need factors that add or subtract from each other to get 1, negative 1. So we'll need negative 5 and positive 4. Hey, we do have something in common on top and bottom, yes? So that's good. Which one do we want to do next? X squared minus 10x. We'll do the last numerator. No greatest common factor. Actually, none of these have a greatest common factor on this problem. So 2 sets of parentheses. Since the 21 is positive, our signs are the same and match the sign of the middle term. So we have negative and negative. Factors of x squared are x and x. Factors of 21 are 1 and 21 or 3 and 7. 3 and 7. Because negative 3 plus negative 7 is indeed negative 10. And that brings us to the last one. No greatest common factor, so 2 sets of parentheses. Since the 12 is negative, our signs are opposite. Factors of x squared are x and x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which one do we want? 3 and 4. Which one's positive? Which one's negative? Because we do want a positive middle term, but also that does give us a common factor of x plus 4 on top and bottom, and x minus 3, yes? Any questions on how we factored any of this here? Now let's see what simplifies. X plus 4 and x plus 4. We also have x minus 5 and x minus 5. And we also have x minus 3 and x minus 3, leaving us with x minus 7 over x plus 1. Any questions on any of this here? We feel good with these here. Yes. Do we want to see 18 or 19? 18. 18, we'll do the same thing here first. Keep the first one the same. Change it from division to multiplication and flip the second. Now we need to factor next. But our first rational expression, x plus 3 and x plus 2, they're as simplified as they get. The only one that actually factors is the 8x cubed plus 16x squared. And again, the first thing we should always look for is the greatest common factor, something that will go into both terms. 8 and 8 and x squared. Because if we factor 8 out of 8x cubed, it's 1. And if I take x squared away from x cubed, we're left with x. Plus 16 divided by 8 is 2. And we get this here. So if we factor 8x squared out of 8x cubed plus 16x squared, we get 8x squared times x plus 2. Well, 8x squared over 8x squared will simplify, yes? And if we multiply it together, we have x plus 3 over x plus 2 times x plus 2. Now the answer key does have this wrong. This should be the correct answer because the answer key just has x plus 3. Yeah, they can't cancel out. Even if I had the first one flipped, it should be 1 over x plus 3 if they did. So I don't know what I was thinking when I was doing this. I probably didn't flip the second and then just started simplifying. But this here is the correct answer. Squared? Yeah, because x plus 3 over x plus 2 squared is the same thing. Any other questions with addition, subtraction, multiplication, division, and complex? We feel good with these here. Solving. Do we want to look at 20 or 21? 20. Now again, with any of the solving, unless it specifically states it, because if there are going to be restrictions come into play, I'm going to state it in the directions or near it saying, hey, check for restrictions. Otherwise, you don't have to because they're not going to come into play. So here, we don't have to worry about restrictions, but we do need to multiply every term by a set expression so that the denominators simplify. One of the ones I know we'll need is x minus 3. Because the one on the right, the x minus 3 and x minus 3 will cancel out. Are all of our fractions reduced? Do we still have denominators? Yeah, we have n. So we'll also need to multiply everything by x minus 4 so that these here will cancel out. Now are all of our denominators simplified? Yes. On the left-hand side, we have x minus 3 times x minus 3 is equal to 4 times x minus 4. Now, just like the last problem, the one on the right, or not right, one on the left, x minus 3 times x minus 3, we could technically write it as x minus 3 squared, but because we're actually solving, we're going to have to multiply it out. It's sometimes better to leave it as this here, because we will need to distribute x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times 3 is 9. We'll do the same thing to the other side. 4 times x is 4x. 4 times negative 4 is negative 16. At this point here, we'll combine like terms. Negative 3x minus 3x is negative 6x. Now at this point here, we do have a quadratic. We have an x squared term, which means we need to get this equal to 0. If we don't have an x squared term, if we just have x, get x by itself and solve. So here, first thing we can do is subtract 4x from both sides. Minus that x squared minus 10x plus 9 is equal to 6. Still not equal to 0, so we can subtract 6 from both sides. Minus x squared minus 10x plus, about to say, minus 16. I dropped the 1 because it was 16 the whole time, yes? Yep. I was about to say that doesn't make sense. Which would be, man, I'm just dropping everything. Because what is our, yep, because the 16 was negative. I didn't just drop the 1, I dropped the negative. Yeah. Which would make plus, and 16 plus 9 is plus 25. Yeah. No, because I knew something was wrong, because if it was 3, there's no way we can take the factors of 3 and get 10. So that didn't work. Even with it being 16, well, 9 minus 16 is negative 7. Factors of 7 still won't give us 10. Now, this here will work. Now, we can factor it or we can graph it. Which one do y'all want to do? Factor. 2 sets of parentheses equals 0. Now again, if there's a greatest common factor at this point here, divide it out. Divide the entire equation by that number. Here there's not. And since the third term is positive, our signs are the same and match the sign of the middle term, so negative and negative. Factors of x squared are x and x. Factors of 25 are 1 and 25. 5 and 5. We want 5 and 5. So x minus 5 is 0, and x minus 5 is 0. Then we would that right there will work. And with any of them, just go on and circle your answer. So if you have it circled twice, that's fine. Circled once, that's fine, because it is the same answer. Any questions on any of this here? Any questions on anything we've done so far? Are you ready for the next one? Now, 20 and 21 are going to be the exact same thing. We're going to solve them the exact same way. Any questions on 23, 24, or 25?
Can we do 23?
Now, with 23, we'll need to factor this here and go from there. Yeah. So x squared minus 2x has the greatest common factor of x. So both of them, we have to factor it out. So x squared minus 2x, we factor the x out, and we get x times x minus 2. The other one is the exact same. And then once we get it factored, now we know we need to multiply everything by x times x minus 2. Now on the far left, well, the x and x minus 2 will cancel with the x and x minus 2. The one on the other side will simplify out, leaving us with x plus 5 minus x times x minus 2 is equal to 1. This one here worked out kind of nicely. The only thing we do need to multiply out is the middle. X plus 5 will stay the same. Negative x times x is going to be negative x squared. Negative x times negative 2 is going to be plus 2x is equal to 1. Now at this part here, we can combine like terms. X plus 2x is going to be plus 3x plus 5 is equal to 1. And again, we do need to get this equal to 0, so we can subtract 1 from both sides. Then it's negative x squared plus 3x plus 4 is equal to 0. Now at this point, we can graph it. We can factor it either one, because if we factor, we'll need to divide by negative 1 so that it works nicer. I'm going to graph this one here so we see both. Negative x squared plus 3x plus 4, if I remember right. Yes. We get this here. And again, we can go second table and see what values of x make the y be 0, which is negative 1 and 4. So the solutions for this are is x is equal to negative 1 comma 4. Or we could say x is equal to negative 1 and then put a little space, say x is equal to 4. Either one of these work. You can put them with a comma or put them as two separate statements. Any questions on any of this here? Now, the ones with restrictions aren't any different than this here. It's just that the restrictions, what makes x is 0, we have to take out. That's the only difference. Any other questions on any of this here? Now, the only thing we didn't get to is solving with the restrictions and simplifying at the end. The ones that we simplify at the end is just factor Numerator, denominator. Cancel what's in common. Any questions on any of this here? If you do come across something you do have questions on, either email me, send a picture of it, email me tonight, or stop by Champ, and we can cover or talk about it then.